earlier segment with our gaming engine, our game engine, and I was mentioning that the game engine really needs the deck to do anything. So we are going to create our deck. So we're stating our deck, or we're declaring our deck as an attribute of game engine, and we start a constructor where we instantiate our deck. And most of the work was already done in the deck class already using our loops. And then we proceed to create a method called shuffle deck. Now this is where the deck actually gets shuffled. Even though the deck may have its shuffle method, that method is called outside of it by the game engine whenever the game engine needs to have that deck shuffled. Alright. Then we have another method called play. Now this play method represents all of the gaming logic that should execute in sequence to actually play our game. So what you'll find inside of this is that it'll have a variable called output. Now what output is it's sort of like a log of all of the events of the game. Since this implementation is very, very basic at present, it's not very visual in the sense that it doesn't show an actual card like the typical solitaire game on Windows and whatnot. It's just basic text. But what the text reports on would be the events of the game itself in sequence. It tells about what cards are drawn. It tells about who has won the game. It tells, it even prompts, for instance. So all of that information will be sent back as a concatenated string in the output variable. So you can imagine whenever the play method is called, it goes through the entire game logic and returns an entire log of what has happened in terms of that particular gaming session. Alright. So we just create our output variable and return it, and in between that we are going to set up our entire game logic. Now, like I mentioned, I've left a lot of room for you to improve on this. Right now the assumptions that are made are that the game will have only two players. The first player will be a human player and the second player will be a computer player. But to start everything off, we have to make sure that we can actually draw cards to facilitate the rest of the game. And this is what this if statement is all about. It's actually going to access the deck's has more cards method, and it just checks to see whether we have more cards to draw from the deck. Alright, if that's the case, then it'll go through the logic. If not, that's in the else case. If not, then it'll say, you know, we have no more cards. Alright, press deal to play again. Something to that effect. And we'll put all the cards back together in a new deck. So we just say deck equal new deck to just prepare for the next game should the user press deal again. Alright, so in the event that we do have cards, we're going to want to shuffle that deck first of all, calling our shuffle method. Or we can say, you know, just shuffle deck. Alright? But we're going to stick to that. That's fine. Either way, it's fine. And like I mentioned, we're going to assume two players. But we're going to need to draw cards for the first player and the second player in that sequence, and we're going to have to differentiate between these two cards. So this is what this variable is all about. This first variable, player 1's card, represents player 1's card, and it's of type card. And I'll show you why in a bit. And to get the first card, we're just going to access the deck's get next card method. And as you can recall, in the get next card method, what happens is that it returns the card that's at the top of the linked list, the first element of the linked list, or the head of the list, but it also removes it from that list, which is what we want. We don't want the user, or we don't want the program drawing the same card over and over. We need to create some sort of simulated deck of cards where we actually physically remove that top card, revealing the card below it, and we continue to do that until the deck is exhausted. So that get next card method will do just that. It will remove and return the first card, the topmost card in the deck itself. Similarly, we can create another variable to represent the computer's card, and here again we call the get next card method again, and this would get the next card after the previous card has been drawn and assigned to the player. Right, so once we have those cards in hand, we're going to use the card class and all of the setters and getters that mostly the getters rather, that we've created in the card class to get some information about the suit, about the rank, but we're mostly interested in the rank and the description in that case. So we can start off by saying, okay, well, tell the user what cards have been drawn. So we tell the user player 1 drew A, and then we don't know that. We insert the particular code that will get the description of player 1's card. It's player 1's card dot get description. Alright? So you can imagine something to the effect of ace of diamonds. Player 1 drew a ace of diamonds. Of course, we know we can make it a bit more dynamic to put an AN if the player 1's card that get description returns a string that begins with a vowel, if you wish, if you want to go that complex. But for now, this will do just fine. Alright, similarly, we can say something like this. Computer drew A, and then we say computer's card that get description. Alright, so that way we would have effectively reported on both cards in the game. Alright, and then we can say we can try to compare those cards by getting the rank of each card. So we say if player 1's card dot rank is more than computer's card dot rank, get rank, returns the actual value, then we say that player 1 wins. Right? What if there's the reverse? If let's say the computer's card, the rank of the computer's card is more than player 1's card, then we say the computer wins. Alright? And what if they draw? We do else if computer's card dot get rank equals player 1's card dot get rank. We have a tie. Alright, at this point we would have exhausted all the possible conditions, but in the event that there's something else, then we say something to the effect of, something impossible happened. Right? Of course, we'll never ever get to that point unless there's some ghost in the machine. Right, so what we've done, we've effectively grabbed the cards, drew two cards. The first card will be assigned to the player 1, the second card will be assigned to the computer, and we reported on the description of the card, if it's an S of diamonds, the king of spades, and whatever. Alright, and we say who drew it, and then we enter this block of code here that interprets the winner and determines, okay, well, if player 1 is a winner, if computer is a winner, or if you have a tie, or if something impossible happens, which possibly would never happen in this case, but we just throw that in since it completes the if-else statements. Alright, now you may have noticed the plus equals, right? Like I mentioned, this output variable contains sort of a log, a step-by-step reporting on how the game actually went in this particular session. So the plus needs to be there. If we take out the pluses, we would only see the last assignment, because everything else would have been overwritten in that sense. But the pluses tell the compiler to say, okay, well, instead of overwriting what's inside of output, we're going to add it to the end of the string in output. Alright? So that's what we want. So if after all of that's done, we can use that same approach to prompt the user. So we say, you know, press deal to play again. Right? Okay, so let's correct this a bit. The else statement should be there. There we go. So right, so that should complete our game engine, and our application itself is more or less finished in terms of the business logic. What we're going to proceed to do now is create our UI and put everything together so that we can test out our HighCardDrawGame. So head over to your projects view and create a new class and call it game window. Alright, so in our game window, we're essentially going to reuse much of the code that the UI code that we've used in the previous exercise, because we're not going to focus on making our user interface too complex at this point in time, since now you're only getting into the language. So we're going to try to keep the UI code as simple as possible. So making it as similar as possible to the previous example should keep you more or less on familiar ground. So inside of our class here, we're going to let game window build upon the JFrame. It's going to extend the JFrame just like the last one did. Alright. Since this is going to be visible window itself with buttons and whatnot. Alright. So our game window is going to have a couple of components, just like the last example, our Magic 8 Ball. The first component would be some sort of display, a JText area. Alright. And the second component would be our game engine. Alright. So let's fix these imports. Okay. Right. So we can proceed to constructor public game window info. Alright, so in our game window we instantiate, in our game window constructor rather, we instantiate those components and set up listeners so that they can respond to button clicks, and then we do some more logic stuff to allow the game engine to take over and report on how the game went. So JText area engine equals new game engine. And we're going to add another component here, a button. We had a button in our last example. In this example, the name of our button will be deal, as in deal cards. And then we could set up a listener on this button, and what this listener would do, it will trigger something else. So we can imagine that whenever the deal button is pressed, we want our play method to execute in our game engine. Alright? And we want the results returned from our play method that executes to be displayed in our display of type JText area. So we do something like this. Add action listener, new action listener. So here is where we're going to collect the log that's returned from our play method. Alright, we'll just call it results. Sorry, not new. It's going to be coming from our game engine, referenced by engine. And we're going to say engine.play. Alright, so whatever's designed in that game engine's play method will execute, and it will return a string containing all of the steps, all of the reporting and whatnot, even the prompts that we've coded into our game engine. And that's going to be stored in results, and then it's going to be displayed to the user by throwing results in the append method of our display. Now the reason why we use the append method is that we want our game to go on and on and on, for instance. And we want the user to be able to reflect on previous transactions, previous sessions of the HighCardDrawGame as he scrolls through those results. Alright? So that takes care of that. Let's fix imports. And the new version of Java has these new things called annotations, and this is just saying that, okay, well, this method is being overridden, but you're going to learn a bit more about that later. Just look at this as setting up an on-click event, so to speak, in relation to JavaScript to just trigger a particular method, alright, or trigger something to process and return results. Okay, let's just look at it that way. Don't get too overwhelmed in this case. So we're going to continue to set the UI up, and we're going to use our add method like the last time. So we're going to add our display, but in this case we want our display to scroll because we understand that our display will hold quite a lot of text over time. So we're going to use another component called the JScroll pane, which adds a nice little scroll bar to our text area should it exceed the viewable dimensions of the window. And it's rather simple to do that. We just wrap it in a JScroll pane and add it. This is a shorthand version of doing that. JScroll pane, inside of the JScroll pane we throw our display. Alright, we use the same border layout. Dot center. Right. Fix that, and we need to add an import for JScroll pane as well. Good. So we have another add method, and we're going to add our button. Border layout south. Then we're going to add a few things to initialize our frame and make sure that it closes very cleanly and terminates our program. That's the first line here. So that little red X at the corner of our frame, whenever we click it, it doesn't by default close or terminate our program. It just hides the frame. So you want to tell the frame to close on exit. And we do that by saying set default close operation jframe dot exit on close. Okay, and set title. That's another thing that we can do. We can say we can set a title to our window, HighCardDrawGame or HighCardDraw, and we set the size of our window, 500 by 400, and we set it visible. Set visible should always be the last thing that we throw on there, because you can really experience some unpredictable results if it's not the last thing that's stated. controls, entire controls won't show up, for instance. So this is our UI. So we've finished our UI, we finished our game engine, we finished our player class, even though we're not using it in this case. We finished our deck, we finished our card, and now we head back to our driver class, which is our HighCardDrawGame, and we just initialize our UI. New game window. There we go. So, it's going to complain, but don't worry about that. Yeah, so, provided that all the code is sound, we can build our application. Should take a couple seconds or minutes. Or hours. Okay, it's finished. And we cross our fingers and run it. And this is what we see. So we hit deal, and it says player 1 drew 2 of hearts, computer drew ace of hearts, player 1 wins, which works. Press deal to play again. Deal. Player 1 drew 10 of clubs, computer drew 3 of hearts, player 1 wins. Well, I'm gonna roll. Player 1 drew 2 of clubs, computer drew 6 of diamonds, computer wins. King of diamonds, king of spades, we have a tie. 2 of spades, jack of clubs, the computer wins. Queen against 9, I win. Ace against 7, you win. 3 against jack, you win. And we can keep doing this. So we can see how everything comes together, all of the descriptions, the logic, the reporting and so on, all of the events, all of the linkages and so forth come together to produce this application that we see here. On the surface it looks very simple, but behind the scenes it's a well organized object-oriented program. And we can keep doing that until we exhaust the pack, at which time it would say we have no more cards, press deal to play again, and we hit deal and we start all over again. Alright, and that's it.